Hello, welcome to Chapter 9, homework questions 27 through 33. Question 27. Solve the following quadratic equations by factoring and using the zero product property, then check your solutions. Alright, on part A, and the directions are asking us to solve all of these using the zero product property. So that means we do need to factor all of them. So the first one will factor into x minus 5 times x minus 5, or you could have written that as x minus 5 squared. Then we'll use the zero product property by setting our factors equal to 0 and then solving. Now in this one, because the factors are the same, we will get one answer at x equals 5, and that means that the graph will touch the x-axis at 5, 0, but it will not cross because it only has that one solution. On B, we have 3x squared plus 17x minus 6 is equal to 0. On the last one I didn't show my work. On this one I will. We'll use the generic rectangle. We have a 3x squared and a negative 6. That means they need to multiply to give us negative 18x squared, but add to give us 17x. So that would be negative 17x and negative 1x. I apologize, it's not correct. About 18x and minus x, or minus 1x. So that would multiply to give us negative 18x squared, but then add to give us 17x. So that looks better. Put an 18x and a negative x here, so that means this will be 3x times x, which means that'll be a negative 1, and then over here should be a 6. You can double check our 6 times negative 1 is negative 6, so that means we'll factor to 3x minus 1, x plus 6, and then we can use our zero product property to set each factor equal to 0, add 1 divided by 3, and subtract 6. So our solutions are x equals 1/3 or x equals negative 6. And there is part B. And then moving on to C, we have 3x squared minus 2x is equal to 5, so we need to subtract the 5 over because we have to set it equal to 0 to use the zero product property. And then we'll set up our generic rectangle again. We've got 3x squared and then minus 5, so we need things that multiply to give us 15x squared, but add to give us negative 2x, and that would be negative 5x and positive 3x. So I'll put the 3x here and the negative 5x here. That means this will be 3x times x, and then that should be a plus 1, and then down here should be a minus 5. And that looks like that'll work out. So our factors are 3x minus 5 and x plus 1. And once again, we're able to use our zero product property to set our factors equal to 0. On that one, we add 5 and divide by 3. And then on this one, we subtract 1. So x equals 5/3 or x equals negative 1. Or we can write it in our set notation here where we have x equals negative 1 and then 5/3. And then our last one, part D. And part D, hopefully you will recognize this one as a difference of squares. So the first and last term are perfect squares and you're subtracting. So that's going to factor to 4x minus 3 and 4x plus 3 is equal to 0. And then once again, using the zero product property, we're going to set our factors equal to 0. So we'll add 3 and divide by 4, and then subtract 3 and divide by 4. So we get x equals 3/4 or negative 3/4. Or we could write it in our solution set here, negative 3/4 or 3/4. And so each of those we solved by factoring and using the zero product property. It does say check your solutions, and so just as a quick reminder to check your solutions, for example on A, we would take 5 and plug it back in to the original equation, and then check to see that we're going to get the left side to equal 0. So negative 25 plus 25 is equal to 0, and that does check. Now, on part B, you have two solutions. So you will have to plug both of them in to check to see that they work. Question 28. Use the quadratic formula to solve part B of problem 9-27 above. Did your solution match the solution you got by factoring and using the zero product property? So let's go back and look at part B. 3x squared plus 17x minus 6. Alright, so on this one we're going to use the quadratic formula. As a reminder, the quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c. And then that whole thing is divided by 2 times a. So a is equal to the number of x squared terms, which is 3. B is equal to the number of x terms, and that's 17. And then c represents your constant, which is negative 6. So we'll plug this in. X is equal to the opposite of 17 plus or minus the square root of 17 squared minus 4 times a, which is 3, times c is negative 6, and then that whole thing divided by 2 times 3. So now we just need to start simplifying things. So underneath the square root we have 17 squared. So that'll be 289, and then negative 4 times 3 times negative 6 is a positive 72, so that's plus 72. And then that's all divided by 2 times 3 is 6. That'll be negative 17 plus or minus the square root of 361 divided by 6. And then the square root of 361 is a perfect square. And so the square root of 361 is 19. So we'll have negative 17 plus or minus 19 over 6. And then we can split this into our two equations. One of them is negative 17 minus 19 over 6. And then the other one is negative 17 plus 19 over 6. Because we do want to simplify these since it was a perfect square. So we'll get negative 36 over 6, so that's negative 6, and then this one is 2/6, which reduces to 1/3. So therefore our two answers are x equals negative 6 or x equals 1/3. And let's go back and check on part B that our solutions do match. So negative 6 and 1/3 for part B. So you can see right here on part B, negative 6 and 1/3. So it looks like our solutions do match, so we do verify that that is the correct solution. Question 29. Find the equation that represents the information given below. So in part A, since it is a parabola, we're looking for the zeros where the graph crosses the x-axis, the x-intercepts as well, so that's at 1, 0, and then this one is at negative 3, 0. And so we know that y is equal to, or even going back, I can actually say 0 is equal to the factors of x plus 3 and x minus 1. Now where did those factors come from? Because my solutions are x equals 1 and x equals negative 3. So I needed to set them equal to 0 by subtracting 1 and adding 3. So that's where those came from. Then we can go ahead and multiply. That'll be x squared plus 2x minus 3. Once again, you can use the generic rectangle to determine that, or you can use the distributive property. So my equation is y equals x squared plus 2x minus 3. On part B, what are we looking for here? Well, we're trying to figure out where those, once again, zeros are. So right here at negative 2, 0. And at 2, 0, those are the x-intercepts. We also can see the y-intercept here, but for the purpose of being able to write the equation, we need the x-intercept. So we can verify that the y-intercept is correct, though, once we write the equation. So on this one, we know our solutions are x equals negative 2 and x equals 2. So this one will add 2 to get it to 0. This one will subtract 2. to get it equal to 0. And so my two factors, x plus 2 and x minus 2 is equal to 0. That'll give us x squared minus 4 is equal to 0. So my equation is y equals x squared minus 4. And to verify the y-intercept I was talking about earlier is, remember, when you plug in 0, this would be 0 squared minus 4, we get negative 4. So we can verify that the y-intercept is correct. But here's your equation for the given table. Question 30. Solve the following problem using any method. Write your solution as a sentence. The length of a rectangle is 5 centimeters longer than twice the length of the width. If the area of the rectangle is 403 square centimeters, what is the width? So it looks like we need to define some variables here. Let's go ahead and say let W equal the width of the rectangle, and then the length, we can just say let L, I'll use a cursive L so we don't get confused, let L equal the length of the rectangle. So now we can look to try to set up our equation. So the length of a rectangle is, that is represents kind of that equal sign typically. So the length, I guess I could use a capital L also, but so the length is equal to 5 centimeters longer than twice the length of the, width. So twice the width, and it is 5 centimeters longer. So there's one equation. The second equation talks about the area of the rectangle. So we know area of a rectangle is equal to the length times the width. So if we say the width times the length is equal to 403 square centimeters, that gives us our second equation. So what are we going to do to solve this? Well, we know the length is twice the width plus 5. So what if we replace or substitute that in for the width or the length? So W times 2W plus 5 is equal to 403. And then now we can go ahead and distribute. So that's 2W squared plus 5W. And then we need to subtract 403 to the other side because we need to set it equal to 0. And then from there, we can solve the quadratic using any method. You know, what is the best method? Well, because C is such a large number, this might be one where we use the quadratic formula. Or if you think that you could potentially factor this one easy enough, you could do that as well. I think I'm going to use the quadratic formula even though I don't necessarily always want to use this, but just because that last number is so large, I think it'll be a little bit easier to do so. So I'm not sure if I'd be able to factor it or not. So the opposite of B would be negative 5. A is 2. B is positive 5. And C is negative 403. Let's just rewrite that. So C is negative 403. Alright, so the opposite of B is negative 5 plus or minus B squared is 5 squared minus 4 times 2 times negative 403 divided by 2 times 2. So that's equal to negative 5 plus or minus. I'm just going to plug that whole thing into the calculator and see what I get underneath the square root. I get 3,249 divided by 4. And then we'll check to see if 3,249 is a perfect square, and it is. So we get x equals negative 5 plus or minus 57 divided by 4. And then we'll go ahead and split it off into two parts. So we either have x equals negative 5 minus 57 over 4, or x is equal to negative 5 plus 57 over 4. And so the first one here is going to be negative 62 divided by 4, which will be negative 15.5. And then the bottom one will be 52 divided by 4, which is equal to 13. Now, if you go back to my original, I actually wasn't solving for x, I was solving for w. So all these x's here, in reality, in my problem, represent, or in this problem, represent the w, because that's what we were solving for. So I'm going to switch them all out for w's just so you can see. Now, run into a little problem here because we have w is equal to a negative 5.5, or 15.5. Can the width of a rectangle be a negative? So even though it solves the quadratic, it doesn't make sense in terms of our solution. So we're not going to use the negative 15.5, not because it doesn't solve the quadratic, it does, but because it doesn't make sense in context of the problem. So it looks like the width will be 13 centimeters. Now, it just asks for the width, it doesn't ask for the length, but if we wanted the length, we could plug the 13 back in to that equation there and get 26 plus 5, which would be 31. But since it only asks for the width, that's all we're going to answer. And so the width of the rectangle is 13 centimeters. And there we go, and that answers the question. Question 31. Which of the points below is a solution to 4x minus 3y equals 10? Note, more than one point may make this equation true. So an equation, a linear equation, has infinite number of solutions. There's infinite number of points that make up that line. So to check whether these points are solutions to the line, we just need to plug them in. So we'll say 4 times, and this will be for part A. So 4 times 1 minus 3 times 2, is that equal to 10? Well, 4 minus 6 does not equal 10, so that one is out. On B, we have 4, 2, so this would be 4 times 4 minus 3 times 2, is that equal to 10? That's 16 minus 6, and 16 minus 6 is 10, so that one does work. On C, we have 7 and comma 6, so 4 times 7 minus 3 times 6 is equal to 10. That's 28 minus 18, and 28 minus 18 is equal to 10. So B and C are both solutions so far. And then for D, we have 4 times 4 minus 3 times negative 3. Is that equal to 10? That would be 16 plus 9. 16 plus 9 is definitely not equal to 10, so it looks like B and C would be your solutions. Question 32. In order to quickly get people between terminals in the Minneapolis airport, long people mover conveyor belts were installed. Assume that if somebody stood still on the conveyor belt, that person would travel 2 feet per second. Since Young is in a hurry, he decided to walk on the conveyor belt in the same direction he would travel standing still. If his terminal is 300 feet away and he wants to get there in 60 seconds, how fast does he need to walk with respect to the conveyor belt, assuming he can ride the conveyor belt the entire distance? Alright, now to answer this question, what I'm thinking is we need to use distance equals rate times time, because we have the distance, which is 300 feet away. We have the time that he wants to get there in. We also know that the conveyor belt is traveling 2 feet per second, but we got to figure out how fast he needs to travel in total to be able to figure out how fast he needs to walk. So the distance is 300 feet away, which is equal to the rate we don't know just yet, but the time is 60. So the rate times 60 seconds. So to solve for R, we're going to divide by 60 seconds. So 300 feet divided by 60 would be 5, and then the units would be feet per second. Now that's how fast he needs to travel. That's how fast he needs to go total. But since he's traveling 2 feet per second on the conveyor belt itself, he needs to walk additionally 3 feet per second to get to the destination in 60 seconds. Now, for B, it says Jacob who is 4 years old, decided it would be fun to walk on the conveyor belt in the wrong direction, in the direction opposite to which he would travel if standing still. If he walks for 18 seconds at a rate of 1 foot per second, how far will he travel? In what direction does he travel? And explain. And so for this one, we know the time is 18 seconds. We don't know how far he's traveling, and so we got to figure that out. But we also do know the rate 1 foot per second, but that's going in the opposite direction. So actually, let's say the conveyor belt is moving this way, and normally you would go 2 feet per second, and Jacob is walking this way at 1 foot per second. So to take the difference of those, we would get 1 foot per second going in the direction of the conveyor belt. So that he's still moving in, I would say, the positive direction here, because he's not walking fast enough to pass the 2 feet per second it's moving. So what we do have is we do have the rate, and that is 1 foot per second going with the conveyor belt. So we can say the distance is equal to the rate, which is 1 foot per second, times the time of 18 seconds. And so it looks like we're going to get a distance of 18 feet in the direction of the conveyor belt. And so once again, for each of these, make sure you are answering the question that is being asked, because it does want to know how far he will travel, but also making sure that you answer in what direction that is going to be also. Question 33, factor each polynomial completely. So since it says completely, it gives me the idea that maybe we have some extra factors, whether they're greatest common factors or whatever, that we need to look at here. So on the first one, I see that there is a 3 in both of them. I also see an x squared that they share in common. So I'm going to use the distributive property going the other way, factoring out the 3x squared. And if we, working backwards, we're dividing. So 3 divided by 3 is 1. X cubed divided by x squared is x to the first. Remember, you subtract the exponents when you're dividing. And then 3x squared divided by 3x squared is just 1. And so that's factored completely. On part B, looks like there is a factor of a 2 in common. So we'll do 2 and then times that by x squared minus 5x plus 6. And then we can factor the quadratic into x minus 3 and x minus 2. Once again, thinking about your generic rectangle, x squared and 6, knowing what factors are going to multiply to give you x squared, but add to give you negative 5x, which would be negative 2x and negative 3x. And so it works out to be x minus 3 and x minus 2. And remember, you put those back in here, and then x, and minus 3 and minus 2. So that's where those came from. And then on to part C. This one has a common factor of 4, so we'll factor a 4 out, and then we can divide to work backwards. That's 2x squared. I take that back. Let's go back there. There's actually a higher number than 4, and that would be the number 8. So let's go a little bit bigger there. We have an 8, and then that would be an x squared minus 4. And then that's a difference of squares, so we can actually factor that quadratic into x minus 2 and x plus 2. And then the last one, D. Put that one over here. And so looking at D, I see there's an x in every single one of them, but there's also a factor of 2. So 2x is what is in common with all those. So 2x, that would leave us with 4x cubed divided by 2x, and that would be 2x squared. 10 divided by 2 is 5. X squared divided by x is 1. X, or x to the first power. And then 24 divided by 2 would be minus 12, and then the x's cancel. So we're still left, this one actually, if you look, was raised to the third power. So now what's left is a quadratic. So let's see if we can also, on top of taking out the 2x, let's see if we can factor this one. So this will be a 2x squared and a negative 12. So what multiplies to give us negative 24x squared? but adds to give us 5x. So what numbers would that be? We need to multiply to give us negative 24, but add to gives us 5x. So that looks like that would be 8x and negative 3x. So 8x, negative 3x. So it looks like this will be a 2x times an x. And then we have a minus 3 here and a plus 4. Double check that. Looks good. 2x times 2x minus 3 and x plus 4. So that's factored completely. So anytime it says factor a polynomial, we should always look to factor it completely anyways. But that's especially looking for those common factors before you start using your generic rectangle, or possibly looking for the pattern of difference of squares or a perfect square trinomial.